mention some part of his biography. Mr. Noori is an instructor in the Department of Architecture at Ajman University, College of Architecture, Art and Design in UAE. He's a practicing architect since 1999, and he has mastered in sustainable design from the University of Sydney 2013. And he has another master in architectural engineering from the University of Technology, Iraq, since 2004. Mr. Noori, he is certified Autodesk professional in urban architecture, and his main field of interest are parametric design and sustainability. He has published a textbook in parametric design and urban and several papers in sustainability and time. And he is an educational influencer with more than 8,420 subscribers on YouTube. So I'd like to ask him, but the picture that I have with your picture now is totally different. Mr. Noori.
Thank you very much for the introduction. I really appreciate it. Thank you very much.
Are you able to share your screen?
Yes, I will indeed. Just give me a second. I hear. So, are you able to see my screen now, dear? Oh, great. Let me push that a little bit up. So, hi. I wish that everyone is doing well and today, and I really thank you for the great introduction that you gave to me, and I also would like to take the opportunity and thank Tishik International University and the Erbil Polytechnic University for the invitation and for giving me the opportunity to participate in this event. I will try today to talk about the computational and parametric design and how they can actually influence the work within the BIM environment. And I do believe that Mr. Twana is, thankfully has been covered the first part talking about BIM, and that will ease the beginning of my introduction to it. And so for him, I really lay thanks. About me, I do believe that I've been introduced properly, appreciately for you, so I'm not going to go through that slide. And just to introduce you about my first textbook book about Revit families and Revit parametric design. It's available on Amazon, of course, and it's talked in details about using Revit family design and the basic of parametric design in it. So my topic today that I picked for you is the computational and parametric design inside the BIM environment. So we are actually here having two main topics, which is the computational and parametric design and also the BIM, which is the, as you all know, the shortcut for the building information modeling and how we can push the limits and extend the limits of what Revit can do, and the building information modeling actually as an overall process can be pushed forward more productive and more creative work environment. So we might ask ourselves the question, what can computational design actually achieve by the help of the building information modeling? And if we reverse the question, what actually computational design can do within this very really important method of work. And to understand that, and I already described that has been covered brilliantly by Mr. Twana, that we need to understand quickly about the building information modeling, and from quick search in Wikipedia you can get the definition as it is a process that involves the generation and the management of the digital representation of both physical and functional characteristics of the place. And this part of the definition is really an amazing thing. It's not only you generate a physical model, so you're not just building a 3D element, you're not building your own design, but also manage. So and the M here is more than in management rather than modeling, to be honest. So you create a 3D model, you manage this 3D model as a physical part of it, and that's what we, most of the CAD application was just generating physical models. Managing was really a weak point, but it's again adding functional characteristics of the places. That means that not only we are modeling physical elements, but we're also modeling a functional, a smart element that actually know their function inside the building. And it's really built the overall thing as a technique of work has been built, and having a 3D elements or 3D model that have to be shared on a cloud or a network base at least, and it's a shared system or shared process between a group of people, not only one person as we use to work with the CAD. So what CAD can provide us, it's really well explained as I mentioned, but for my point of view, the best thing we got ourselves a smart element. Instead of a line, two lines that represent a wall, we got now a wall as an actual physical functional element, a smart element that understand its function, know its price, we can know its price, we can know what it's made of, its inside anatomy, the structural part of it, and if it's an interior and exterior. So we have a new revolution way of defining the elements that we have. We have a smart elements that have a full set of data information, and that's what I just described here in point one. So it can be, the information can be stored, that can be analyzed, it can be reformed, it can be represented, and that's what we're going to come later what the computational design actually did for it. BIM as a smart elements has the capability to recognize others, and it have to recognize, or it can actually recognize its relationship to other elements. So now we have a parameters, and how can I say it? We have a column, a smart element that knows that it's actually carrying a slab above. So if I increase the height of the slab, the column actually carrying it knows that it have to extend its height to carry it. So BIM actually starting to give us the opportunity to link those smart elements to each other because they actually recognize their actual function. So there is a bidirectional relationship between the elements. So it's a two-way relationship. You can change one element and it will change the other, or you can change the other and it will change the first one. The bidirectional relationship, or a two-way relationship, it can be defined not only by or with the physical elements in the model, not with the doors and windows, but can be actually established even with the dimension and the other annotation. So if you change the dimension in AutoCAD, it won't affect the model, but if you change that in Revit or in the BIM environment elements, you actually going to be changing the physical model too. And same for the views, by the way. When whatever you change in one view, it will be reflect back to the other view. BIM actually stored the 3D copy of the model on cloud. This is an essential work to reach BIM, not only as software, which is the Revit itself, but it's, you can have an object that's shared by all. They will be notified that the change is happened. You don't need to pick the phone and call your structural engineer telling him that you did something in this specific level, but rather if you use the full BIM environment, specifically we need to talk later about the BIM 360 that facilitate this process. And when you actually do open the schedule or a plan, it's actually going to see a revision cloud or a highlighted element of what changed, and that will cut the human error by me or the civil engineer or the architect not seeing the changes happen during the design process. This is the beauty of BIM as an overall concept, bigger than the concept of the software itself. So again, you can reflect the information you are doing as a schedules. You can create sections, you can create elevations. You don't need to draw them anymore. You don't need to revise them anymore when you change something. And this is the couple of very few picked of the topics that BIM actually can do. So if I summarize everything, or summarize at least the slide that I giving, that I have a 3D model. It's usually stored on a cloud or a shared. It can be reached by more than one user. So the architect could be in UAE, the engineer it could be in Australia. For example, the structural design could be in India. And that's what we have in one of the company that I work in Australia. The structural design was actually in India. He wasn't in our homeland. So all of them work on the same file exactly on the same time. We can see each other updating the parts of elements, which is something of definitely the CAD process and its all platforms cannot do in the easy way. This 3D model actually has an element or a smart element, which is walls and slabs and so on. and in the same time it can generate plan section elevation automatically. The elements you create have something called parameters, which is the features, the main features, the main aspects of it. It have length, it have width, it height. Of course, the list goes really long for each one. I'm just putting 3 of them. And the slab have the same thing. And of course, when you change the height of a wall, it will change or in effect immediately the height of the slab. And you can see the two-way arrows that represent the bio-directional relationship, which is the two-way relationship that can be affect the model. And of course, those changes will be reflected back and updated to the model itself eventually. Now, the second terminology, or the second thing we really need to understand and know, is the computational design. Computational design is really an important topic in the architectural design process, and it depends on having, of course, a computer as a design tool and as a method of making, not just to draw as a drawing tool, but it's a method of design. And it also can help you to be, or actually the computer can be a decision maker instead of, using the computer as a drawing tool only. Computational design, of course, enable us to create the required design option. It can be create one option of the design. It can create more than one option in the same time. And you can see the images beneath. All of them represent a lighting fixture. All of them are the same model. All of them are the same geometry. But anytime you like, you can click a slider or a fader that can change the amount of vertical louvers. As you can see, you can change the height of them. You can change how many rotations they actually do against each other. So what you see here, they are not 6 different models. They are the same model built in Revit, but controlled by a computational design platform that can give you infinite amount of possibilities of your design, infinite amount of possibilities of your of your aspect, of your shapes, of the elements and the number, the material, and the list goes on, because it's feed on the parameters that BIM provide for us, take those parameters and actually can control and change whatever you want in them. So what actually computational design can give us, or what is it actually? It's a design process that requires you to understand textual or visual programming. The best tools, of course, will be Dynamo and Grasshopper. You have to understand what is algorithm and what is the logical steps behind it. The process that defined clearly in the code. So you have to take your thoughts, the way you design, put them in a very basic code, and the ideas will not be shared and limited inside your head only. The use of computer power in order to do this process, this is a really important thing now. The computer will not be your design tool. It will be the designer. It will be your second hand and your second brain. And it's mainly designed to create an advantages. It invent and smart one option, but you can push that limit and you make unlimited options of your design. Of course, it can make a very highly complicated design that cannot be done in AutoCAD. It doesn't have the plans and section clearly in it, but it have more than one option, more than one elevation in order to be described. Focus on the process. You have actually, in order to achieve a computational design, you have to think of the process rather thinking of the design result itself. So if you have not previously met or understand the concept of algorithm, the algorithm is a group of logical steps that related to each other that can define anything. So if we took this as an example, designing this pattern, design this tower or whatever you want, based on a repetition of a rectangle and changing its rotation or height, then you have to take the idea you want to design with. You take your thoughts from your brain, tell the computer, teach the computer how to design it. So you have to take the rectangle, define X and Y, and of course you have to tell the computer to make a copy, rotate that copy with a specific rotation angle you want, and then tell it how many times it have to do that. So if you want to do that once, which is this one, okay, just one rotation, 45 degrees, that's it, one copy, and the result will be finished. If it's one iteration, one repetition, the design will finish, everything will be fine, everyone will be happy. If you say the iteration or the amount of copies you want is like 5, then it will loop itself, that now there is a logic that you cannot program, and you cannot do that in a normal Revit platform, but you need a computational design tool, similar tools used by lots of pioneers in this field, like Patrick Schumacher and Zaha Hadid. You have to tell the computer to think. Now you give order that it's 5 of them, so the computer will keep repeating the model and then send it back to Revit. If you need a 12, that will be the result, and so on. So this is the algorithm. This is how you teach the computer. It's very basic steps you can learn and make Revit design a complex, way much more complex geometries. And if you don't know what is a visual programming, of course, most of us know the scary one, which is this one, which is the textual programming. Everyone hates it. No, don't worry, everyone is scared of it, not only you. This one is the visual programming, which is very famous now. It's way much more easier. And instead of creating a box, you have a node for creating a box, and you can link that to a small other node. So this is the commands, and in order to achieve, this is the inputs, and that's the outputs of them. Of course, Dynamo is the computational design platform available inside Revit, and it's completely free. And it's, of course, Autodesk product. It's part of the Revit itself and some other products in Revit. So in order to understand how they all link together, we get back to our self model, the element that we got from Revit, the 3D model, and those length and width and height for each element. All this information can be sent to a computational design platform. So this is the side where the computational design platform work. Of course, you're going to control it by Dynamo or a visual programming tool. So in order to be a computational designer, to do and design like Zaha Hadid, you have to understand these tools and you have to work with them. Of course, they're going to be input values, which is what the information you get from your BIM. Give it to the process, to the algorithm. Here inside this black box, of course, it's not a black box. There is a process, there is analysis, there is a comparison, optimization, whatever you think, whatever you need, you got to define that to the algorithm, and it give you the outputs. Maybe the output you need is to create 10 towers instead of 1. And those 10 towers will be sent back to the 3D model in Revit, and Revit will create for you 10 towers. You don't need to remodel that 10 times in Revit. If you need to make 200 or 3,000 elements of a stadium, which I'm going to show you here in the next example, you're going to do that in a couple of seconds, not hours, not days, seconds, when you use the computational design platform. Send back that, send the thing you want. Of course, you're not going to send 20,000 or 10,000 model to Revit. It's going to be explode. Of course, the best computer will not take that, but you're going to compare the options you got and then send back to Revit to do it for you. So back to our question, what we can gain and harvest from the computational design and how it affects the building environment, building information modeling. I do believe the first option is to get multiple design options. So instead of, this is the stadium, by the way, for Shenzhen in China, and I remodeled that. You can see that, you can see the full tutorials available on YouTube in my channel. And the basic is I have to understand what he was thinking. I assume that this is circle. I know this is not a circle. It's an elliptical shape, but I assume it just to make it easier for an educational purposes. I make this circle and I define the points. It's 1, 2, 3, 4, 5 circles. I think this one is the 6th. Excuse my weak memory. And each has a set of a point that have a specific height. And each time I change the height of those points, this one or this one at the outside or the inside, if I change the radius or I change the height, I get a different possibilities. So how many options I get, how many tower I get in Dynamo, I get exactly, I think, 30 or 20,000 design options. These are just 16 of them. You can see the YouTube, you can see there's a long list of roof design for that stadium. You can pick whatever you want, and the one that you like, you can right-click and export it back to Revit so Revit can do it for you. So why you want to design one tower, why you design one house, why you design one stadium, when you can design a 10 or 100 or 1,000 of them? And then you pick which one is good. Let the computer do the design job for you. I'm not talking about the computer to draw it for you. No, I'm asking to let the computer to design it for you. And that's happened because you teach the computer in a couple of steps how to design, what's in your brain, what's your method of design, and the computer will reflect that back with all the options. So the first point is, as I said, is to give you the multi-options And as you can see, the picture on the left, you can show you like a funny way of representing or representing or suggesting the Windows location on a building. Here, I think this is a master thesis for a lady. She's also she's from Germany, and she is also computational design. Also, she is a famous YouTuber. I think Autodesk adapted that as a very good example. You can see those plans. It is automatically generated, and the function has been distributed differently in a different location in a couple of minutes, of course, by using Dynamo. And I'm not sure if you use Dynamo or Grasshopper, but the same technique. It's computational design. Other example, or the second point actually, is you can achieve not only one target, but you can make more than one target. So you have one criteria in the previous example, which is distributing the window or getting a roof design. In this example, you can have one criteria and compared by it and have the full analysis of it. So it can give you the best option or the worst option. That means one criteria, or you can have multiple criteria. And for example, here, random seed, average distance, the cluster spacing, and you tell the computer that I need that value to be from 8 to 7, and that value to be from 30 to 40, whatever, and that value from 20 to 60. Focus on those options. And the computer goes with the computational design, finding thousands and thousands of design proposals, and then pick for you two only, which is those, that meet the best out of those multiple criteria. So you can design that to give you multiple option. You can design computational design to give you the best option that achieve one criteria, like less area, more area, more expensive, less expensive design, or you can make the computational design, give you the best view and the least price and the tower design that you want, if you understand my point of view. So multiple option, achieving the best out of one criteria or achieving the best of multiple criteria. And of course, the computational design, and sorry, I'm a bit quick because I have a very tidy time frame. I think I left 5 or 10 minutes left. Of course, you can have your computational simulation or on any tower, and you can see this in the generation manual, generative design premier manual, how you can see the red dot and the yellow dot and orange dot to represent how much solar energy you get on your tower. The list goes on and on for the amount of daylight you can get when you test a specific skylight. So each skylight, it will have its own feature. You can make a serious wide range of research in this field because it's really fresh. And you can see that each design option has been tested, and you can, by a look, understand that those are the best or the worst. It depends on the climate, if it's cold or hot, what you want. You can have a look of the comparing spotlight design, and just go 700 millimeter to see how many energy how much light you can get on a horizontal surface, and how that will be achieved, if it's overlit or underlit, it's too bright or too dark. You can see that in a couple of seconds and let the computer decide for you. You can see there is a way long list. This is one of the YouTube, also one of the nodes I also made that make the computational design it's actually run a plan. As you can see, this plan is very simple. It can be for a hospital where you have hundreds of doors. And as you can see in the example, that Dynamo is just, catching the doors that doesn't match the minimum requirement of the government. For example, in the municipality, in the design hospital, the door width shouldn't be less than 1,000 millimeter. For example, it is, I think, 1,200 millimeter. But anyway, let's say 1 meter, and you design that, or you get the design from someone or a contractor, and it's huge, it's like 1,000 door, and you are not going to click one door by itself to see each door how wide it is. And instead, you can go for a computational design tool. In a couple of seconds, it can check which door is wrong, put a circle, and even if you want, it can be replaced by using Revit and building information modeling to replace those wrong doors and replace them with the correct one that meets the municipality criteria. There is endless possibilities of what you can do. Dear friends, you can add automatic dimension, the nightmare for all the engineers. After you finish design, put the dimension. It can be put in a click one click, by the way. You can design a complex form. This is the model I made. It's a representation of the lava team for a tower here in Abu Dhabi. And of course, you can see the complexity of the geometry. Here, it's also been designed based on an algorithm. It isn't designed based on accumulation of shapes. You can end up by having endless profiles, if you believe me or not. All of them are the same plan, but they have different inputs for the setting. And when you complete them vertically, the Dynamo and order Revit to give and create the shape that it needs. And again, complex shapes, the list goes on and on and on. Some examples of the tower. You cannot design that in AutoCAD anymore. You cannot get an elevation for that anymore, a normal elevation for that anymore. It's useless actually to get an elevation for it. And now Dynamo can get you or the computational design platform can get you the detail for each piece of your model and how big it is and how you cut it and how you manufacture it. And it's even curved in a 3D. It's not a pure projection for any specific surface, so you can make an elevation for it. So here we open the door for a robotic design to make this type of complex building. Of course, the nightmare of design, when you have a plan and you want to solve it, or you have a big land and you want to know where is the road and where is the areas of the lands and villas you want to design. It can be designed in a couple of clicks. This is the PhD presentation of, I think it was Jesse and Davey. They just add up with a function that can automatically design and divide the area for streets or walkway, whatever they are doing, and then give you the rooms, flats, or whatever distribution in a couple of seconds. Of course, one of the best in the industry is TestFit. They are the pioneer in that, and you can see that they manage actually to design. The software is available yet into the development process, but can be very, very useful. And you can see that the computer is actually, when you move the points, the plan is actually changed automatically, and the parking area, as you saw, it's actually been redesigned automatically. And not only that, but it's actually getting your 3D shapes for it, and you can see that can be with a couple of clicks instead of painful hours and painful days in AutoCAD. And you can see this, there's endless examples, endless possibilities of any design area. And of course, each unit you see, it's actually been pre-designed as a block, if you allow me to say. To take a reference from AutoCAD, you can see those block. They are not a block, of course. We are talking here a fully computational design platform. And with the moving of a line, you can redesign the entire building. If you are still happy to use AutoCAD, well, mabruk, bidanya, go use AutoCAD and spend hours and hours doing the old thing incorrect. You see how he moved the elevators and stairs, and everything is updated automatically. I can imagine everyone who works in the architectural field to remember how painful the process is to do this. You can now do it with the moving of a mouse. They are one of the best companies in the field, and you can see now how they can actually give you endless possibilities of any design for each lot of areas that you can find in your site. If you are a structural engineer and you have the nightmare of getting crazy shapes out of the architect, and you want to design for them a lattice or structural design, it can be done in a couple of clicks. If you are an MEP or a BIM manager or an architect, senior architect who try to do the clash detection, you will understand the nightmare of checking the work of the MEP and electrical and how the pipes are hitting the ducts. Now it can be done, a clash detection report, a 3D clash detection report, a smart 3D clash detection report that it can tell you which element is hitting where and when, and even some of the application, if you program them nicely and easily, it can fix the issue for you automatically. Other applications, sadly, I cannot go longer than that because the time available for me is very limited to allow others to give their ideas. That's been presented in other topics, in other webinars. You can check my YouTube if you want to have a look for more detail about each one of those topics. So thank you very much again for allowing me to participate in this event, and thank you very much for all the audience for listening to me. Appreciate it.
thank you very much, Mr. Firas, for your amazing presentation.
Appreciate
I
it.
couldn't stop you, even you have passed the limit for 5 minutes, but it was really amazing topic.
Very sorry for that. Sorry for that.
Thank you. So we can take your discussions, dear audience, and your comments. So we can say this is really a huge revolution in engineering.
Well,
So we had,
yep.
yeah, we had a blueprint drawing 2D, which was very hard to visualize the other dimension. Then CAD is popped out, like computer-aided design, to visualize the third dimension.
Yep.
And now we have BIM, information modeling, which is beyond 3 dimension.
Yep.
We, in this presentation, really, we felt that there is more than 3 dimensions in the construction projects in this program.
Yep. If I presented that for more than like a 2 hours lecture for the University of Technology webinar that I prepared last month, how actually the whole digital platform evolved, starting from CAD and up to the generative design, even further than the computational design. It's like more than 2 hours lecture. It's available on my YouTube for free if anyone wants to watch it. This topic is really critical because lots of, if we talk about it in an educational way, lots of universities still sadly stick to AutoCAD as its only platform to design, and some of them are just introducing 3D Studio Max or SketchUp, and that's it. The rest is, abrupted. So we are teaching. I'm talking about that, and as an academic, not only as a designer. Sadly, lots of universities still stick to teach technologies invented in the 1980s, like AutoCAD. And let's think it's 40 years old technology. It's more than enough, And BIM revolution started in 2000, yet lots of university and lots of offices struggling to adapt it so far. So that is really sad. Now we have the best available tools, but sadly, it's not been introduced properly, not to the industry, and specifically not to university, which is making it even more dangerous. I don't know if there is any more question. I'm more than happy. I think Engineer Rusty have a question.
There is no question. May I just shoot rather a profile question?
Go ahead, please, Doctor.
Dr. Noori, what I would like to understand, how did you pick up your skills? Is it academic skills or industrial skills?
Which one specifically? The architectural ones or the computational ones?
No, not the architectural.
Or the BIM ones?
Your presentation was about, it was
yes.
A lot of technicality in your presentation.
Yeah.
I wonder this technical part of your professional profile is taken up to the academic or professional?
Okay. Well, for me, I start up in BIM as 2013. I get my certificates from Autodesk. Then I find out that implementing Revit, I'm not talking about the soft, let's say the soft BIM, not the hard BIM. The soft BIM was a big change and a big jump, and it's really a promising thing. And then I have introduced myself, accidentally I was keep digging deeper in Revit, and I found out something called Revit families, which is significantly sad to see all my students depending or dealing with Revit families as it is a block in AutoCAD. So whenever he wants or she wants to have AutoCAD blocks, she go to the internet and download some beds and chairs and put them in a project. They do the same in Revit, and this is what is actually killing Revit and preventing it from doing itself. They don't want to know, they don't want to learn anything related to parametric design. And by digging in this field, I learned that Revit have the ability through the Revit family design, which is a platform inside Revit for free, can create for you any furniture you want, any design element you want, any room you want, any building you want. So I learned accidentally actually that the Revit family design is a parametric platform. That opened for me, you know, like 3 years of studying, and I even published a book in February about that, my work for the last 3-4 months in the subject of Revit family design, introducing and teaching myself from internet and from online courses and LinkedIn what is parametric design and how it can be done inside Revit. Eventually, to find myself in 2016 are not getting enough and cannot do everything I want inside the Revit families. So I knew that there is something called Dynamo and there is something called computational design, and it's more developed than parametric design. There is difference between parametric design and computational design. Computational design is higher than the parametric design as a concept. And then I started for 3 years, actually now 4 years, studying computational design, which opened the field for something higher than computational design, which is the generative design. And all of that has been introduced either by myself work, internet search, YouTube search, and specifically I got lots of skills because I always podcast my work in YouTube. As a YouTuber, I am a YouTuber, actually educational one, and I learned from a significant amount of knowledge from this question of my student. Some student asked, how can I do this? And I don't know. So I told him, I don't know. So I go search and I found that in order to do this job, you need to learn this thing. And I get back the answer for him. And in the same time, I go study it. So next time when someone else asks me on YouTube, I know what to do. So this is specific knowledge. I didn't study it like Patrick Schumacher or Zoha Hadid or any one of those famous in AA School of Architecture or the Stuttgart University, which is they are more like than a pioneer in teaching digital architecture and computational design platform. Sadly, I was mainly interested in sustainable design rather than the computational design when I was studying in University of Sydney. Even when I studied in Australia, I didn't study that. I studied sustainable design. But throughout the work, and YouTube specifically, I've been developing something else, which is this one. I wish that my answer actually met what you need, Doctor.
I wanted to hear that story because it's very interesting that academia has failed to address the needs of the market and trying to regulate their education somehow to respond to the needs of the market.
Yep.
What we are doing, especially in this region, we prepare our engineers for not even 1960s concept and level of critical adjustment to what the construction industry is striving and heading at.
Yep.
I don't know whether you are familiar with the optimization process in construction design.
Yep. I'm a bit familiar with it because as an architect, I have less knowledge in structural design, but as an optimization, it can be done in one of those platforms, and there is lots of plugins that can ease the pain.
What you showed graphically here,
yes,
actually backbone of that platform test that you showed here, or any other application that make changes quickly, is optimization process.
Yes.
There is an algorithm that took years at the start to come up with the right way of processing the alternative form for certain unit or certain construction.
Yep.
And this optimization is one of the major important field at the moment for structural engineers. And as you know, now we are heading towards the construction industry that ABC actually is one single package.
True.
When it comes to education, because these engineers, when they finish, they need to understand each other. They need to understand how they work with each other and how they respond to each other's layer of responsibility during the process.
True.
And suddenly we are in the region that you get the curriculum to teach, and then when that curriculum you go in depth and look into the sections of that curriculum, you will understand that the most of the stuff that you are teaching is so that there is no market for you to learn the basic one, the hard one, and the solid information that has been around since 1960.
Yeah,
And even you
true.
have forgot to mention it now. And we have a lot of painful adjustment that we need to do in the region. Thank you very much.
Thank you.
Thank you. Thank you very much, Dr. Dylan.
Alexa, please.
Hi, I have a quick question because I use both like Dynamo Grasshopper and now Grasshopper is also inside Revit. In your opinion, which one is better? I know it depends what you have to do, but in your opinion, which one is better? I didn't decide yet. That's why I wanted to know your opinion because I really see that you're an expert in Dynamo.
Well, thank you very much for the question, Dr. Alexia. Well, that's my nightmare, the one that you just asked about. You're touching the painful issue, you know. Look, let me be frank with you. There is almost, I asked my wife, Dr. Nadine, yesterday, what I have to do. I'm sick of this. I was asking her a word by word, letter by letter, your question. And she smiled and she said, you will figure it out, my honey, you will figure it out. There is almost no clear answer for that, but let me tell you the pros and cons. Dynamo is the computational design platform built specifically for Revit. So there is no comparison. If you want to be fully BIM integrated in Revit, there is no escape of learning Dynamo, sadly that. It is more integrated. It is more able to control the Revit elements. So you have two environments similar to the Grasshopper environment. You have in Grasshopper we have the actual Grasshopper, and then we have to bake the result to the geometries of from Grasshopper to Rhino. I'm not really an expert in Rhino, but I have lots of friends and I watch lots of YouTube about it. But the issue when they created the ability to connect Rhino to transport all the information to Revit, it's a big revolution. So it might give you the rest not to go and learn the pain of Dynamo. Of course, Rhino is faster. Rhino is easier. Sorry, Grasshopper is faster. Grasshopper is easier to learn, just to be honest with you. It is easier to model because it doesn't have to bake all the time automatically the elements back as a geometry. It is still as an element. So the 3D, the thing you design is still a geometry, something inside the Grasshopper brain. It doesn't need to be exported as a real geometries, as a real lines, walls inside Revit or inside Rhino, whatever the platform. This makes it super fast. Rhino have I think 2004, I think, no, 2007, I think, has been in the industry. So it's older by, I think, 7 years from Dynamo. So yes, there is a big community over there, lots of pre-made plugins, more than Dynamo. So that's the advantages of it. Sadly, Rhinoceros, and it is not a fully BIM, it's not a BIM platform. Dynamo is been integrated with Revit, and it's a full integrated process. You don't need to go exporting and importing things. I advise you to learn them both. This is my sad, ugly advice. You have to learn them both. You must learn them both because
I know them both, but I just wanted to know your opinion.
Yeah.
Because I had a little bit of trouble learning Dynamo because it's different. You have to think.
It is rigid. It's a bit rigid. Let me be honest with you. Yes, well, we have to say that. All right. So we are to feel really relief. It is a bit rigid, but they keep developing it every month, and the people working in it as a number is exponentially increasing, and that's something promising. And I am learning Grasshopper just as a sabotage process. So I will take the knowledge from Grasshopper and translate it to Dynamo. Trust me, this is, if they know about me, they will cut me off and block me. This is my main purpose. I'm learning a Grasshopper to take the knowledge that they discover and give it to Autodesk Dynamo to make people love more to use Revit and love more to use Dynamo. So yeah, that I'm going to learn more in deep Rhino, so that, and Grasshopper, if you ask me, if you ask about that too. I wish that answered your question, Doctor.
Yes, yes, thank you so much.
Most welcome.
Someone raising the hand, Engineer Rusty. Are you still there?
Hello, everyone. Thanks for your presentation, Dr.
Most welcome.
I have two questions.
Go ahead.
I know the name of program building. I want to know this program is working on road construction or not. The second one, this program is working in Kurdistan successfully or not?
Okay. What is the name of the program you are asking, dear?
BIM generally.
BIM generally, if you are talking about the BIM as a software or BIM as a design method, which one you want, have you?
Yes, as a software.
As a software, there is two main design platform for it, which is ArchiCAD, the two most famous one, which is a European product, and there is a Revit, which is the American, almost copy of it. So both are operable. You can use both of them in anywhere in the place. I lived in Kurdistan for like 2 or 3 years, and I used it to design any type of shapes, any type of building I want, and then to deal with the fact that lots of civil engineers and lots of other architects doesn't support Revit files. I just easily can export the work from Revit file to DWG, and you got all your layers, material blocks, everything you want been prepared for you. So the client, the other structural engineer, the other mechanical engineer that you're going to deal with, he doesn't even know that you create this in Revit. So the answer is yes. If you want to use Revit softwares, you can, and you can do that in any place. Either if you're talking about Revit as a design method, so you need to buy something called Revit 360. It's a cloud-based platform that allow you and all your design team, wherever you are, whether you are in India, you are in Iraq, you are in Australia, Kurdistan, wherever you are, you can all work on the same project, even if you are from a different disciplines. So in order to achieve the big concept of a BIM, you have to work on Revit first, and you have to buy BIM 360, both of them, my dear.
Thank you. We have ended up the second presentation.
Thank you very much.
And almost the break was also is now done. So we will start to the next seminar, which will be presented by Mr. Shad Sherzad.
Could you answer Mr. Zaid? He raised his hand.
The time is almost end. We cannot take more questions, please, because even the break was...
if you allow me to interrupt, Mr. Ziad, you can just contact me on Facebook.
Yeah.
I'm very happy to answer you there, okay?
Okay. If kindly, Mr.
Thank you very much.
Share your YouTube channel here.
I will, and I share my information there, so if everyone have a question. Thank you very much. Have a lovely one.
Please, Mr. Shah.